Let's solve the following, simplify the following expression. So we have 2 square root 19 plus square root 17 plus twice 2 square root 17 plus square root 15 plus square root 15 and multiply by 19, square root 19. Okay, let's break into parts and simplify. So first, 2 square root 19 plus square root 17 equal. So to rationalize, meaning to get rid of square root or radical. So the only way I can get rid of the square root if I square it, right? Therefore, I'm going to leave it 2 here, and in denominator I'm going to be able to square it, I'm going to multiply by square root 19 minus square root 17. Why? Because I'm applying formula a plus b, a minus b is equal a squared minus b squared, right? Okay, so this is going to be equal. Same thing I'm doing to numerator, because whatever change you do to denominator, you have to do to numerator as well. Minus square root of 17. So this is we are going to be equal. So square root of 19 squared minus square root of 17 squared. Because here we have a plus b, a minus b, right? Okay, so in numerator we get twice square root of 19 minus square root of 17. So as a result, we are going to get twice square root of 19 minus square root of 17. Here we get 19 minus 17. Because 19 minus 17 is equal to, so I can cancel these 2 and 2. And the result is square root 19 minus square root of 17. Okay. Now let's move to rationalize the second part of expression, which is 2 over square root 17 plus square root 15. It's going to be equal to, okay, let me move it down. Okay, square root 17 plus square root 15 and multiply by square root 17 minus square root 15. And here multiply square root 17 minus square root 15. Okay, from here, what do we get? We are getting twice square root 17 minus square root 15, right? And in denominator, it's going to get square root 17 squared minus square root 15 squared, right? A squared minus b squared. Okay, so from here we are getting twice square root 17 minus square root 15 divided by 17 minus 15. And that is going to be equal. So 17 minus 5 is 2. And I can cancel with these 2. And the result is square root 17 minus square root 15. Now let's put together the entire expression. So we have 2 over square root 19 plus square root 17. Let me rewrite in different color. Okay, plus 2 square root of 17 plus square root of 15, yes. Okay, and then we need to plus square root of 15. All this multiplied by the square root of 19. And we are going to have the following. First piece, we had a result square root 19 minus square root 17, right? That's the first one. With this minus. Second one, or maybe I'll do this way. 1 second. It's better way to do like this. Okay, next we are getting plus. So result of second fraction, we got square root 17 minus square root 15. And this is this one. And plus square root 15. And all this multiplied by square root of 19. Okay, so what do we get here? Let's see. Cancel each other, and we have square root of 19 multiplied by square root of 19. And the answer is 19. Okay? All right. Next question. One minus x squared under square root minus 1 and over x multiplied by 1 minus x and 1 minus x squared plus x minus 1 plus square root 1 plus x square root 1 plus x minus 1 minus x. Okay, before we solve this, we need to find the domain because we have here denominator. And for the domain, first of all, look here. Domain, x cannot be 0 for the second. So since we have 1 minus x squared square root, I have to put condition x has to be greater or equal -1 less 1. Yes? Why we put the requirement x has to be within -1 and +1? Because if x is more than 1 here, let's say, and or less than -1, the result 1 minus that number is going to result as a negative number, which cannot happen with square root. All right, so what I'm going to do next, before I write down, I would like to do some drafting so you would see. If I have square root 1 minus x times, let me see, times 1 plus x, that is equal square root 1 minus x squared. This regarding this one. Regarding x minus 1, it's going to be x minus 1 is equal square root 1 minus x times square root 1 minus x is equal 1 minus x. Okay, here we have x minus 1, but we'll take care of it, don't worry. I understand that x minus 1 and 1 minus x, two different stories. But we will make it x minus 1, we'll convert into 1 minus x. So I'm going to use these properties. Oops. All right. So let's see. What do we have here? Square root 1 minus x squared minus 1 divided by x multiplied. So in denominator, I'm going to take out 1 minus x. Look here, when I am, if you compare these two, here I have 1 minus x, here I have 1 minus x. And what's going to be left over in parentheses? It's going to be from 1 minus x squared, there will be left square root 1 plus x. Now, I have plus x minus 1. I'm going to put minus sign plus, switch on minus. And in parentheses will be left 1 minus x. What did I do? X minus 1. I can rewrite, put negative sign and write down 1 minus x. Why is that? Because I flipped the position or flipped the sign of both of them. Okay? See, if I open this, simplification or this change, if I open parentheses, I will get still negative 1 plus x, which is the same thing as this one. I'm just put negative in front and switch positions because it will change the sign also, right? Okay, therefore I will have 1 minus x left in parentheses. And in numerator I will have 1 minus x. Okay, so plus, I put here plus, and it's going to be same simplification I'm doing there. Same changes, rather saying 1 plus x. Okay, and in actually 1 plus x, 1 minus x, yeah, I can't do here anything. And minus square root 1 minus x. All right. So going further, it's going to be equal one minus x squared minus 1. In denominator I have x. This is pretty much self-explanation. Now with this fraction we are going to have here so I'm going to 1 minus x here represent, look here, 1 minus x as a 1 minus x times 1 minus x. Or I can write down 1 minus x, oops, 1 minus x, square root of it, squared. And in denominator I still have square root 1 minus x. Here I have square root 1 plus x and minus square root 1 minus x. Okay? and plus, it's gonna be square root 1 plus x, and in denominator we will have same thing, square root 1 plus x minus square root 1 minus x. All right. So here I'm going to simplify or cancel 1 square root 1 minus x and square root 1 minus x. Okay. And from here, what I'm going to do, I'm going to bring now to common denominator the two fractions in parentheses, in square brackets. And I'm going to have square root 1 minus x squared minus 1 over x multiply. So we ended up with the same denominator, yes? That was the purpose actually from the very beginning. When I saw here square root 1, because we have addition, right? So I compared the denominators and I saw that I can bring this one, I can bring to this format. Okay? That's how I started working. And now we have common denominator square root 1 plus x minus square root 1 minus x. In numerator we will have 1 minus x square root plus 1 plus x square root. All right. Now, from here, what we're gonna do? This part we leave alone. 1 minus x squared minus 1 over x. Now, with this fraction here, I have a problem with having square root in denominator. So I need to get rid of it, rationalize, just like I did in the previous problem, right? Therefore, how can I rationalize? Looking at the formulas, the properties I put here. So I have a squared minus b squared. Oh, I don't have it here, but I'll write down. It's not a big deal. A squared minus b squared is equal a plus b, a minus b, right? That's the only way to get rid of it because I have to square each term, square root 1 plus x, and then square root 1 minus x. And that will get me of the square root. So, times, I'm going to do square root 1 plus x minus square root 1 minus x, and I'm going to multiply square root 1 plus x and plus square root 1 minus x. Let me change the color here. And the same change I'm going to do to numerator, right? So I have square root 1, oh, one more attempt. Okay. Square root 1 minus x, right? Plus square root 1 plus x. And I am multiplying by square root 1 plus x plus square root 1 minus x. So same multiplication as I did into numerator, denominator. All right. Well, let's see the result. So 1 minus x squared minus 1 over x times, so we have in numerator plus and plus. See, here I have plus and here I have plus. So it's going to end up with 1 square root 1 minus x plus square root 1 plus x and all that squared, right? But in denominator, I'm going to get square root 1 plus x squared. And why is that? Because here I have subtraction, here I have addition. So in this case, at the bottom, I'm using a minus b times a plus b, which will be a squared minus b squared, right? And in numerator, I will have a plus b times a plus b. Okay. So this is going to be 1 minus x squared minus 1 divided by x times. So a plus b squared in numerator is going to be a plus b squared is equal a squared plus 2ab plus b squared, right? So let's apply. A squared is going to be square root 1 minus x squared plus twice square root 1 minus x times square root 1 plus x and plus square root 1 plus x squared. Okay. In denominator, we are going to have square root, squared of square root. It's going to give me 1 plus x. And here is going to give me minus 1 minus x. Okay. Moving forward. 1 minus x squared square root minus 1 over x times. So square root 1 minus x squared is going to be 1 minus x plus. I'm going to have 2 square root 1 minus x times this one. Remember what we had here? I wrote down. It's right here. 1 minus x squared. So 1 minus x times 1 plus x, it's going to be 1 minus x squared, right? And square root 1 minus x squared. And plus this one will be 1 plus x. Divided by 1 plus x minus 1 plus x. So 1 and 1 is gone. All right. And we are going to get, in numerator also, x is gone. So I will have 2 plus 2 square root. Okay, let me write down. X squared minus 1 divided by x. Multiply. Here is also, we have 2x. Right? X plus x. And here we have times 2 plus 2 square root 1 minus x squared. So from here, I have 1 minus x squared minus 1. Here we have 2x squared, right? Multiplication. And here I have, taking 2 out, I have 1 plus 1 minus x squared. So These 2 will be cancelled with these 2. Look what I have. Practically 1 minus x squared minus 1, 1 minus x squared plus 1. So result is going to be, so 1 minus x squared and minus 1 over x squared. This is gone, and the answer is going to be, this is also gone. So the answer is negative 1. And let's do the third one. What do we have here? We have radical degree 4 from x cubed minus radical degree 4 of x divided by 1 minus x plus 1 plus square root of x and radical degree 4 of x. All this squared and times 1 plus 2 over square root of x plus 1 over x, and all this negative 1/2. So what I'm noticing, first thing, we have radical degree 4 and we have the square root, which means radical degree 2. My first goal is going to bring them to the same degree of radicals so I can combine them, right? So before we start working on it, let's identify what is going to be our domain restriction. So next, degree 4 of x. With this one, look here, degree 4 x squared. If I rewrite as a rational exponent, I'm going to get x2 over 4, which is going to be equal x2 1/2. That means I can write down here square root of x minus 1. It's beautiful, right? And here we have 1 minus square root x. Look here, we have similarity. All I have to do, place negative sign in front, and I will get the same expression, and I can cancel them. Okay, plus 1 plus square root of x over radical degree 4 of x, and all this squared. Now times. What I'm going to do here, in numerator, I will have square root x plus 1 squared, right? And in denominator, I have x, and all this to power minus 1/2. Okay, so next step, what it's going to happen, I put negative in front, square root the radical 4 from x, radical degree 4 from x, and let me change different colors. I get 1 minus square root of x because of this negative sign I put in front, right? And I have also 1 minus square root of x, and I will end up canceling each other, and plus 1 plus square root of x over radical degree 4 of x, and all this is squared, all right, times. Now, since I have here negative 1/2, since it's negative sign, I'm going to flip it, right? So it's going to be x to power 1/2, or x instead of x to power 1/2, I put square root of x, and square root of x plus 1 squared if I raise to power, okay, let me do step by step. I keep saying, and I don't believe myself that I am making clear for you. Okay, I'm flipping. For now, I'm flipping. Okay, x here, square root of x plus 1 squared, and all this to power 1/2, right? We got negative, get rid of negative exponent. So from here, we have negative radical degree 4 of x plus 1 plus square root of x over radical degree 4 of x, and this is squared, times, so x to power 2, it's going to be square root of x, that's what I was talking about, and this 2 to power 1/2, it's going to be square root of x plus 1. I'm going to bring here to common denominator the first parenthesis, that is squared. So it's going to be negative. Common denominator, it's going to be radical degree 4 of x, right? So it's going to be here. Let me put here. Okay. So here I will have radical degree 4 of x times radical degree 4 of x, right? Plus 1 plus square root of x over radical degree 4x, and this is squared, and times square root x over square root x plus 1. So this is give me let's see, radical degree 4 of x times radical degree 4 of x. That's going to be radical degree 4 of x squared, right? Which equal x to 4th, which is equal x to 1/2. So I have the negative square root of x in denominator degree 4 of x plus 1 plus square root of x, right? This is to power 2, where successfully I'm canceling these 2, and times square root of x over square root of x plus 1. And finally, since we have a square here, 1 squared is going to be squared, and square root degree 4 of x squared, it's the same thing, degree 4 of x squared, which is same way we're going to get x to 1/2. So which is square root of x. And multiplying by square root of x times square root of x plus 1. We are canceling here. Yes. And all we have left, we need to rationalize this the square root in denominator. Yeah. So I'm going to rationalize. Obviously, since I have square root of x plus 1, I'm going to do square root x minus 1 to get rid of this square root in denominator, rationalizing. Which means here also, here is also I will have square root of x minus 1. Yes? And the result is equal square root of x minus 1. And here we get also x, because a plus b, a minus b, right? That's going to give me x minus 1. Or if you like, you can write down 1 minus square root of x. We're changing on both sides. That's why negative sign doesn't stay there. Oops. I mean 1 minus x. I'm sorry. 1 minus x. Okay, I'm done. I would highly recommend people who are interested to learn this type of problems, I would highly recommend after watching this video, you write out these problems and try to solve on your own. Those are advanced level problems for future engineers. Okay? Okay, dokie. See you next video. Bye for now.